Okay, first of all, let me start by saying we have now simplified radicals. We have added, subtracted, we've done some multiplying, and we have done some dividing. We are now going to continue with multiplying and dividing with binomials, so two terms. I also need to let you know that when I videotaped 6.5 in the next session, I actually accidentally put 6.4. So please note in your book which section you're in, as the next video I wrote the wrong section number down. Okay. All right. So let's take a look. We know what a binomial is. A binomial contains two terms. So let's take a look at operations with binomials. We have to add or subtract, because remember, subtraction is the same as adding the opposite. We have multiplication. That can also include powers. And then we have division, which we know technically is multiplying by a reciprocal. So I actually don't need to write it separately. Okay. First of all, let's say I ask you to simplify. We're going to do one of these because you actually already know what to do. Let's say I give you the binomial 1 plus the square root of 3 added to 2 minus the square root of 3 minus 5 plus 4 square roots of 3. Now I really honestly feel one example is enough, because we are adding and subtracting, which means we simply combine like terms. So if I take all the whole number or integers and I combine 1 plus 2, distribute the minus, and a negative 5, then I'm going to combine all my like radicals. Square root of 3 plus a negative root 3 minus a 4 root 3, and you probably may have done this mentally. We end up with 3 minus 5 is negative 2. Those reduce, cancel each other out. So I ended up with a negative 2 minus 4 root 3. So I keep my whole number part separate from my radical part. Okay? Or you could have written it as a negative 2 times 1 minus 1 plus 2 root 3. I'll accept either one. Okay? That's it for adding and subtracting. Multiplying, okay, you actually already have the concept. The concept hasn't changed. We know how to multiply binomials. We have done FOIL in the past. We have done the distributive property. In this case, if I ask you to simplify, so notice there's no equal sign. And let's say I have 1 plus the square root of 2 times 1 plus 3 square roots of 2. Well, we've done multiplication in the past. We can use the distributive property, or we can think about distributing using a pattern of first, outside, inside, last. Either way, it's the same thing. If I first distribute the 1 to the first term, and then I distribute the 1 to the outside term, there's the first two terms. There's the first and the outside of FOIL. Then if I distribute the square root of 2 times 1, those are the inside terms. And then if I distribute the square root of 2 times 3 root 2, that's my last term. 1. 4 square root of 2 plus square root of 2 times the square root of 2 is 2 times 3 is 6. 7 plus 4 root 2 is your answer. So we could use the distributive property to simply expand that binomial multiplication. So we're practically done, because the concept we've done before, we just didn't have radicals in the problem. We didn't have roots. All right. So what if I write something like, here's problem number 4. The square root of 5 plus 2 quantity squared. Well, when in doubt, write it out. I highly recommend you take the time to write it out so you don't accidentally miss a term. This is not multiplication. You cannot simply square both of them. This says there's 2 terms. So do exactly what you did in chapter 4 and FOIL it out. Multiply it out. First term, square root of 5 times the square root of 5. I'll write it out. Outside term, square root of 5 times 2. Now distribute the 2. Inside term, 2 times square root of 5. 2 times 2 represents the last term. And then combine like terms. And you should get a final expression of 9 plus 4 root 5s. Okay? So I have confidence that if you write it out, you should be fine. Should be fine. Okay? So notice we've already done adding and subtracting. We've done multiplication and powers. And of course, there's more examples in the book. Let's take a look at division. Now, before we look at division, I want to remind you of a fact. I want to remind you of something that we did back in chapter 4. I want to remind you of something you already know instead of you memorizing something new. So what I'm going to do is let's just do a little recollection from chapter 4. Okay? I'm going to leave this first line blank. I'm going to give you examples. If I gave you x plus 2 times x minus 2, when you FOIL that out, your first term gives you x times x. Your outside term is negative 2x, and your inside term is positive 2x, so the terms canceled. And your last term is 4. Okay. If I gave you x plus 3, and I gave you the sum and difference of the same 2 terms, the terms being the x and the 3, notice first term times first term is x squared. Again, your outside term of negative 3x cancels with your inside term of positive 3x. So you're just left with your first terms times your last terms. Following this, if I give you x plus y, x minus y, our first terms minus our last terms. And so in chapter 4, we talked about these were the sum and difference of the same 2 terms. And notice the middle terms are always canceled out, and we're left with the difference of perfect squares every single time. Okay? These are what we call conjugates. Conjugates. Conjugates, when you multiply conjugates together, right, you will always get the difference of squares. So anytime you multiply conjugates, your inside and your outside term will always cancel, and so you're just left with the difference of the perfect squares. Okay. So if I give you x plus the square root of 2, okay, what's the conjugate of x plus root 2? Well, it's going to be x minus the square root of 2. And whenever you multiply those out, those are the sum and difference of the same two terms, you will always get your first term squared minus your last term squared. So you'll notice by multiplying conjugates, we've eliminated the radical completely. We've eliminated that. So where are we heading? Well, we've done addition, we've done subtraction, we've done multiplication. Let's take a look at division. Dividing with a radical. Now I'm going to first start with one we've done in the past. The only division we've done so far has been with a single term. For example, if I gave you 4 over the square root of 3, we know that we cannot divide by the square root of 3, and so we had to rationalize. And so we divided by, we multiplied by the number 1, and we rationalized. And when we did this, we ended up with 4 root 3 over 3. And then we were rational because the denominator was no longer a decimal that went on forever and ever and ever. It was no longer irrational. Then if you recall from just like last week, let's say I had two terms. Let's say I had 2 plus, I don't know, how about the square root of 2 divided by square root of 3? Well, we still looked at the denominator. The denominator still had a radical. There's only one term in the denominator. So we chose to rationalize. And when we rationalized and we multiplied by 1, since we had 2 terms in the numerator, we had to distribute. And when we distribute, we got 2 times the square root of 3 plus the square root of 2 times the square root of 3 all over 3. So when we had 2 terms, we had to distribute. So that's what we did back in sections 6.1, 6.2, 6.3. Okay. Now, let's take a single term. Let me see if they've got one handy. Here's number 8. Okay, so here's number 8. They gave us a fraction, 1 over 6 plus the square root of 3. Well, right away, you should be realizing, oh no, oh no, oh no, we have a radical in the denominator. We're not allowed to divide by an irrational number. So we need to rationalize this. Well, if I only, here, do not write this down. Don't write this down. Don't write this down. Don't write this down. Okay, put your pencil down. Don't write it down. If I only multiply by a root 3, but I have 2 terms down here, as soon as I distribute, I'm still going to have a root 3 in the denominator. So I haven't done anything. If I have a root 3, if I have two terms and I only multiply by the root 3, this is wrong, don't do this. You'll notice we haven't really fixed it because we still have a radical in the denominator. So don't do that. You're smarter than that. Analyze what you have in the denominator. Okay? In the denominator here, we have two terms. So because I have a binomial, I want to multiply by its conjugate because the conjugate will eliminate the middle term. So now, trust me, now we want to multiply, but we want to multiply by the conjugate. So instead of 6 plus root 3, we want to multiply by 6 minus root 3. Of course, I need to do the same thing to the numerator because it's just multiplying by the number 1. And then as we said earlier, anytime we multiply conjugates, you're left with the first term squared minus the last term squared. Anytime you multiply by conjugates, you're left with the first term squared minus the last term squared. So anytime you multiply by conjugates, you're left with your first term squared minus your last term squared. So if I now multiply by these conjugates, in the numerator I have 1 times 6 minus root 3. In the denominator, because they're conjugates, I'm going to be left with the first term squared minus the last term squared. Of course, you can FOIL it out. And when we do that, we are left with 6 minus root 3 over 33. So if you have a binomial and one of the terms, or both, one of the terms has a radical in it, you want to use its conjugate. So let's look at number 20 as well. Number 20, square root of 6 divided by the square root of 2 plus the square root of 3. Well, as soon as you see a radical in the denominator, we've got to think, cannot divide by that irrational number, so I need to rationalize. Because we have two terms, we need to use the conjugate. So I'm going to rationalize by multiplying by the conjugate of the square root of 2 plus the square root of 3. So the conjugate of the square root of 2 plus root 3 is the square root of 2 minus the square root of 3. Alrighty, I'll go down for a little more room. So when we distribute, I'll be literal for the moment. Square root of 6 times 2 is the square root of 12. Square root of 6 times 3 is the square root of 18. And then you'll notice the denominator is conjugates. Well, the product of the conjugates is always the difference of perfect squares. So the first term squared, root 2 times root 2 is 2, minus square root of 3 times the square root of 3 is 3. Now we will simplify. 12 is 4 times 3, so I'll come back. 18 is 9 times 2, so I'll come back. 2 minus 3 is negative 1. 2 root 3 minus 3 root 2, all divided by negative 1. So if I divide by a negative, that's going to change the signs if I change this sign, this positive 2 root 3 becomes a negative. This negative 3 root 2 becomes a positive. And our denominator is, whoops, sorry, I ran out of room. I'll go over here. That would become a 3 root 2. Let's try this again. Third time's a charm. 3 root 2 minus 2 root 3. Am I still on the board? No. So I've set it now. Divide both of those by a negative, so each of these signs will switch. This will become a negative, this will become a positive. So we're left with 3 root 2 minus 2 root 3. All right. Okay. So that's the beauty of dividing with two terms. Just use the conjugate. And then you all know what a reciprocal is. Reciprocal is turn it into a fraction. So I'm going to end with, here, I'll make this example up. Here we go. Find the reciprocal of the conjugate of 2 minus the square root of 5. I'm just making this one up. Because let's just look at the vocabulary. Let's just look at the academic language. We want the reciprocal of what? We want the reciprocal of the conjugate of 2 minus root 5. All right, let's first start with what's the conjugate? Well, if I gave you 2 minus root 5, its conjugate would be 2 plus root 5. So I took care of the conjugate. Now it says find the reciprocal of that. The reciprocal of the conjugate is, we all know how to find a reciprocal. Turn it into a fraction and, quote, flip it over. There's the fraction, 1 over 2 plus root 5. You found the reciprocal, but you're done, but you're not finished. You're done because that is the reciprocal. However, you're not finished because it's improper to have a radical in the denominator. So now let's rationalize. So I'm going to start with my 1 over 2 plus root 5. Hopefully you're already seeing where I'm going with this. I can't have a radical in the denominator, so I'm going to multiply by its conjugate. Conjugate of 2 plus root 5 is 2 minus root 5. And now if we simplify by multiplying straight across, distribute the 1. And if we FOIL out the denominator, our first terms are going to be 2 squared. Our outside term and our inside term will always cancel with conjugates. And then we're left with our last term of 5. 2 minus root 5 divided by negative 1. So now a positive divided by a negative makes that 2 negative. Negative divided by a negative turns that radical positive. So we are left with the square root of 5 minus 2. There you go. So it all comes down to academic language. All right, so that's a lot of what this year is about. It's a lot of what high school is about. Learning to analyze what you're given. So there you go. So please remember, when you go to the next section, 6.5, in the video I accidentally labeled it 6.4. So 6.4 is binomials containing radicals. 6.5 is equations containing radicals. All right, you guys, have fun with this. And if you need more examples, simply ask. See you next time.